Okay, so 6-3, this one is dividing polynomials with synthetic division. Okay, so our objective is to divide polynomials using synthetic division. Now, synthetic is like fake, you know, like you have a synthetic substance or a synthetic, like I know that there's sometimes like synthetic oils that go into cars or, you know, different kinds of synthetic things. I just think of it, synthetic oil off the top of my head. But it's like a fake division. So we are still dividing, but it looks completely different. It gets the job done, but it's just a different way of doing it. Just like synthetic oil, it gets the job done. It's, you know, it can go in your car. However, it's just different. It's a different approach within your engine and all of that stuff. Let's look at using synthetic division. Okay, so the directions are divide using synthetic division. Okay, the one big thing is, remember that it's dividend divided by divisor. Your divisor, the coefficient for x must be 1, positive 1, okay? So I don't know whether you remember in the notes yesterday, I said you can use long division if that coefficient is something other than 1. So if you ever have a divisor where the coefficient of x is 4 or 2 or whatever, you must use long division. But if the coefficient is 1, you can use synthetic division. So let's look at that. So we have number 1, I have n squared minus n minus 29 divided by n minus 6. So notice in my divisor, the coefficient for n is 1. So you're able to use synthetic division. Okay, just like some cars can't really use synthetic oil. So it's, you know, it's all dependent on the car. So it's all dependent on the kind of problem if you can use synthetic division. So what I do first is I make a little box. And the number that goes here in that little box, what I do is I can set this equal to 0 and solve. So n equals 6. So 6 is the number that goes there. Okay, so the first step is to set your divisor equal to 0 and solve. Whatever number you get, that's the number that goes inside the little box. Okay? Then what you do is you write the coefficients. So if you notice, I have an n squared, I have an n, and I have a constant. Okay, so I write those coefficients. The coefficient for n squared is 1. The coefficient for n is negative 1. And then the constant is negative 29. Okay, then you leave a space and you draw a line. So the synthetic, it's a fake division, and we're actually going to be doing kind of opposite of what we do in long division. The first thing that you do, you have to bring down whatever your first term is. So that's 1. Then what I do is I take this 6 and I multiply it by the number here, by 1. So I'm going to do 6 times 1, and that answer goes here. So 6 times 1 is 6. Then, to get this number in that place, I have to add those two numbers together. So in long division, you normally subtract, but in synthetic division, you add. So negative 1 plus 6 is 5. Okay? I'm going to then do the same thing. 6 times 5 gives me 30. And so then I have to do negative 29 plus 30 is 1. Okay? So, one thing that you have to know is that this number here, that is always your remainder. Okay, the last number is always the remainder, so I know I have a remainder of 1. And then you work backwards. So I have my constant. My constant is 5, and it's a positive 5. And then my next number, so what comes after the constant would be an n with the coefficient of 1. So we kind of work backwards. So your final answer is 1n plus 5 with a remainder of 1. Okay, let's look at another example because I think it might get a little bit easier if you look at it again, because right now you might be freaking out a little bit, but it's not too bad. A lot of people actually prefer synthetic division over long division. So let's look at another problem. I have x squared minus 74 divided by x minus 8. So I get my box. So I do x minus 8 equals 0, x equals 8. So 8's what goes here. So I've got my x squared, and then I need an x, and then a constant. Well, my x squared's coefficient is 1. I don't have an x, so I'm going to have a 0. And then it's my constant. My constant is negative 74. So then I leave a space. I bring down my 1. And 8 times 1 is 8. 0 plus 8 is 8. 8 times 8 is 64. Negative 74 plus 64 is negative 10. Remember that this is always your remainder. Okay? So we have a remainder of negative 10. We have a constant of a positive 8. And then this is going to be a 1x. So I work backwards. So that 8 goes there, that 1 goes there in front of the x. So basically it's always remainder, then the next number is constant, and then the next number is going to have the x, and then you might have an x squared, depending on how long the problem is. Let's take a look at another problem. So my final answer here is 1x plus 8 with a remainder of negative 10. You could also just write that as x plus 8, remainder negative 10. Okay? Let's look at a third problem. I have k cubed minus 5k squared plus 8k plus 4 divided by k minus 1. So I have my box. So I have to do k minus 1 equals 0, k equals 1. So I have a k cubed, then k squared, then k, then constant. So the coefficient for k cubed is 1. The coefficient for k squared is negative 5. The coefficient for k is 8, and my constant is 4. So now I draw my line. Bring down the first term, which is 1. So 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 8 plus negative 4 is 4. 1 times 4 is 4. And then 4 plus 4 is 8. So remember, that's my remainder. And so I have a remainder of 8, a constant of a positive 4, and then the next piece I'm going to have a linear term, so it's going to be negative 4k, because that's where I got that negative 4 from. And then I'm going to have a k squared in this case, which that 1 is going to go there. Okay? So then my final answer is 1k squared minus 4k plus 4, remainder 8. Another approach that you can take is your answer. Notice that the degree of your answer is always 1 less than the degree that you started with. So if you don't want to work backwards, if you want to work forwards, then what you can do is you can just start with 1 degree less than what the problem actually started with. So now we're going to look at a couple other problems that are more ACT related with using synthetic division in the next video.